Hello, good day, Imagine. Today is April 28th. We are going to have a review lesson based on scale drawings. Let me get this video started. And I want to make sure I keep it pretty simple. But scale drawings are, for those of you that remember our geometry lessons, they're simply a dilation. So if you look at two figures that are essentially identical, but have different sizes, you're looking at a dilation or a scale drawing. That's it. So you find component parts and you multiply them by whatever the scale factor is. There you see the figures, right? They're moving around. They're same figure. They're just changing sizes. Guess if you actually really want to get technical, they did kind of change shape though. All right, we have a plant here. And we'll just take the example of a plant in a store, and it's just a model plant for people to buy. And it has a base in yellow of 6 inches and a height in red of 18 inches. Okay, you have someone that comes into your store and they want to buy that plant, but they want the adult plant. They think that plant's a little too small, and they come in with the schematics for their house and they say, well, I need this a little larger. Again, we're looking at a dilation. The question becomes, how much do you want to scale this up, right? So you have your blueprint, you have a scale factor of 5. So that means whatever plant we're looking at in the store, we need that, but 5 times larger. All right. And again, this is what our scale drawings do, or our scalings do. We take our component parts and just scale them up. So we'll take that 6 inches and the 18 inches and we'll multiply them up, or multiply them by a factor of 5. We'll multiply by a factor of 5. Okay. And that will give us our new scale. So in yellow, we have 6 inches times 5, which will give us 30 inches for the base of our new plant, and 18 inches times 5, which will give us 90 inches for the height of our plant. Okay. That should be pretty straightforward. So I will fast forward to our next example. We can look at a plane. So let's take 2 planes in the sky. We have a real plane, right? Like a 747 or something, and it's 250 feet. We have another plane that is a model plane flying behind it, and we would like to determine the size of that plane. We don't know it, but we are given some information about it. The model plane was built with a scale factor of 25 in relation to the larger plane. So in the example before, we created a larger model based on the smaller version, so we had to multiply up. Now we're going to divide, so we'll take that 250 divided by 25 in order to get the size of the smaller plane. And that 250 divided by 25 would give us 10. So we expect the model plane flying behind this airline to be, we'd expect that to be 10 feet. Okay. Now, one place you see a lot of scales or scale drawings would be with maps. So for your homework, what I want you all to do is look at this map and tell me how long you've traveled in miles. So if you were to start at the start point and you're on some, I don't know, a camping trip, and the only thing you can do in terms of traveling is move vertically or horizontally. All right. And I tell you, you're going to start at your start point, move to that northwest region where the camera is, then move to the fishing hole directly east of it, and then come back home. If you take the shortest path possible, how far have you traveled in miles? I want you to show your work. You can submit this via email, screenshot, whatever. What's your what we've been doing before. Just submit the work. You have 2 days. So if today's Tuesday, this should be done by what? Wednesday, Thursday? I guess by Friday morning or Thursday night. If you have any questions, reach out to me. I'll have office hours. Who knows? I'll probably stay on or float around until 1 o'clock. I believe that's my time. But yeah, good luck, and let me know if you need any help.